we're going to hit welding terms really quickly, okay? The arc is just an electric short we can control. That's what we're welding. We're going to create an arc, we're going to melt metal, we're going to turn it into a puddle, and then we're going to manipulate. And by the way, doing it overhead is just as easy as doing it here. You're doing it right, it won't drip. Don't worry about it. I'll show you, okay? To weld the fusion of metals. All right, when we talk about welding, we're strictly talking about melting the two, bringing welds to their melting point and sticking them together. Soldering and brazing and all that is more like glue. And I'll go into that. Yes, ma'am.
Can you make a metal base and then weld glass into it?
No. No. All right. Back pass. That means that you're going to weld on one side. We're going to do the whole weld. We're going to do this weld right here. We're going to weld this whole thing up. And then we're going to come back around to the other side here, and we're going to gouge this back out, and we're going to weld it again from the other side. The Chicago Bridge test involves that. I can give you more details on that another day. It's one of the hardest structural tests to pass. But if you got that one, you got it made. The Chicago Bridge pays really well. Flux. The two things that will wreck a weld faster than anything else are oxygen and hydrogen. Now, where would we find oxygen and hydrogen?
Oxygen is found everywhere. We breathe one.
Yes. What about hydrogen?
Oxygen and hydrogen make clouds and fog and things. So technically you would find it in the sky and in clouds, but on Earth you can...
Everywhere.
Yeah.
The answer is everywhere. Right? In fact, when the metal is cold and we heat it up, I can show you on a cold morning when we're out there, with cold afternoon, we get a cold day, we're out there welding. I'll take a torch and I'll show you how we can cook the water right out of the steel.
Yeah.
Okay? So flux, what flux is designed to do is it's a powdered chemical. This is a welding rod. It's covered with flux. The stuff that's in here is the direct opposite. Let me do this up here real quick. On a welding rod, you have a metal center with the flux on the outside. With the flux core welding wire, you'll have the flux on the outside and the solid wire around it. All right? And I'll go into more details on that another day. And all this is a chemical that when we create the arc, it's going to burn off and it's going to create this cloud of gas around the arc that keeps the oxygen and hydrogen at bay. All right? And there's even specific rods called low highs or low hydrogen welding rods. Those even have to be kept dry before you use them because they'll soak up moisture and it'll wreck how they work. Okay? This is a cellulose-based rod. It's an 80-10. I'll go into what that means too. And by the way, most of you, there's lots of people out there that call themselves welders that do not know what those four numbers mean on a welding rod. And no, the last two digits are not the length. I'll get to you in a minute and you can show off.
Oh no, I'm waving to you.
Oh, why?
The number thing.
Oh, yes, I know, and I'll let you tell them in a minute, okay? So that's all the flux is designed to do. It's so that when we weld the two metals together, they stay welded. We have a solid structural weld. When we're done, that weld should be stronger than the metal around it. All right? And we'll show that out there. Slag. Slag is what collects on top of the weld from the melted flux. All right? That's all that is. Rods, this, the electrode. All right? Acetylene. Acetylene is a highly combustible gas and a lot more dangerous than most people know, but it is the best welding gas in the world. It is the only gas that I can use to melt two pieces of metal when combined with oxygen to a temperature that will allow them to melt so that we can weld with it. You can't do that with propane, you can't do that with natural gas. Again, one of these days we'll go into a lot more of that. Bond is just making sure that the metals stick together. The base metal is the plate that I'm welding on. This would be a piece of metal, I'm going to strike an arc on it, I'm going to weld it. This is the base metal. Sometimes the base metal and the welding rod have to be the same. Sometimes we intentionally want them completely different. And sometimes we're going to use a welding rod that doesn't actually weld, but actually is designed to be placed over the piece of steel to protect the piece of steel from high temperatures, corrosive chemicals, or abrasions, or impacts, or all four. All right? And I will go into a lot more detail of that. You want your kids to fall asleep? I'll just stand up here and talk about welding rods and filler metals and hard surfacing. And by the way, this is a great book if you want to learn more about it simply. Okay? And these books here, these pocket welding guides, Don't buy them secondhand. Usually they charge more for them secondhand on eBay and Amazon than you buy them brand new. They're a great little reference. On your cell phone, the one I like, I gotta bring this one up. I have an app called Piping and Fabrication, and it is really cool. It has a couple of welding calculators on it. It has all kinds of neat stuff, and there's a lot of reference material about welding rods on it. And they send you a daily tip, but by the way, that comes up, the tips, there's only like 30 of them. So eventually, you get the same ones over and over again. Corner joint is when we've got two pieces like this, and I'll actually show the kids one day. You can do it with a TIG welder really easy. You can do it with a acetylene welder, a little bit with the stick welder, where we're not going to use any filler metal. All we're going to do is heat these two pieces of metal up, and we're just going to let them fuse together all on their own. It's really kind of cool. Great way to build like toolboxes and stuff. Straight polarity, reverse polarity. Electricity, these light bulbs are the wrong ones. Model airplane people have a little timing device that they can point at the prop on their airplane, and what it does is it shoots a little light beam out there that you can't see, and it sees every time the prop interrupts that, okay? Now, if I was to point that at a regular filament light bulb, it would tell me how many RPMs that prop is turning in that light bulb, because the electricity here in this room is AC. So you constantly have positive and negative sides of the electricity just moving back and forth, all right? You can weld with AC power. I have AC welders. There's a few tricks to it, and I'll show you some of them, okay? But when we talk about DC welders, that's direct current, not alternating current. So one side is positive and one side is negative. I don't want to argue about it, but it goes from negative to positive, okay? And it always goes that in a complete circle, around and around and around and around. Well, sometimes we want straight polarity, which means the part that I'm holding in my hand, that stinger, or this nozzle on this gun, that's the negative side, and the clamp around this side is the positive. That's straight polarity. In reverse polarity, this is the negative, and this is the positive. And all this machine does is produce that, takes AC electricity, turns it into DC electricity, and then allows me to control it. And I can switch things around or hit a button or something and reverse the polarities. Yes, ma'am?
You said not to buy the pocket books for Amazon.
Okay.
Really?
All right. So that's just a quick overview of how the electricity travels through our joint. All right. Drag, horizontal distance between the point of interest. That one's wrong.
That's what it came up.
Okay, that one came up. Drag means, am I going to drag the arc behind me, or am I going to push it in front of me? We're going to push or pull. If it makes slag, go ahead and drag. Remember that all the time, all right? Right, Abby? You heard that one yet at school? That's a good, not all, most, like this welding process here, mine I can push it in either direction. Mine I use as a gas instead of a flux to protect the arc. So I can really go in either direction. I drag a lot just because I find it easier. All right? If you're pushing, one of the advantages, you're preheating things out in front of you. With an acetylene torch or a TIG torch, you really need to push because you need that heat out in front of you. A lot of TIG techniques, you can't go the other direction. It just doesn't work. All right? But if it makes slag, go ahead and drag. So we're going to strike the arc here. We're going to go in this direction. All right? But yeah, that is something. The next page in our book talks about American Welding Society classifications, and it talks about different types of weld. Joey, will you come up here for just a second? Come on out here where everybody can see you. All right? Joey has sat through this class so many times and hears me talk about this stuff so often. All right? Now, hold that welding rod and read the numbers on it. What's it say? Can you read it? 80-10. 8, 0, 1, 0. Okay? What do these two numbers mean, Joey? No. Sebastian. The tensile strength in pounds of square inches times 10,000. So an 8010 has 80,000 psi of holding strength. That rod there is typically used in pipeline welding, downhand. We'll go into that in a lot more detail another time. There might be 3 numbers, as in 1, 10, 18. Same thing. Those first 3 numbers, all that is the tensile strength of the rod in thousands times 10,000 pounds of psi. The number 1 means. Oh, come on. You just raised your hand. You wanted Sebastian.
No,
Position.
no, you were talking about how people that don't know the stuff.
Oh, okay. Yeah. Oh, okay. Yes. The 1 is the position it can be used in. And just a rule of thumb, a 1 is every position, up, down, forward, sideways, backwards. Or an odd number is all positions. An even number like a 4 is only in the flat position. You cannot run the rod any other way. Just the way the flux melts. And I'll go into that in a lot more detail. A number 2 is the same kind of thing. And then the last number typically has something to do with what kind of flux is on. Right? Right? That's typically what that means. Right? And that's what those numbers on the rod mean. And this gives you a lot of detail about that. And I believe maybe even go into some about what the wires are. The E stands for electrode, that kind of stuff. Go to the next page. Welder's parts and functions. Shielding gas, like I said, some welders require a gas. Usually it's an inert or it's an inert mix. What does inert gas mean? What does inert gas mean?
I'm not doing gas.
It's a type of gas. Type of gas.
Non-flammable, yes. It's non-reactive. It's not a gas that will mix with anything else, which is really funny because the ones you buy are usually a mix. It's usually not all argon. It's argon and carbon dioxide, or argon, carbon dioxide, helium, or some combination thereof. All right? You have the power source, which, like I said, all it's doing is taking AC power and turning it into DC power and giving us a way to control it. You have the welding wire, which this machine's backwards. But that's the filler metal that we're going to use. You have the ground. You have the stinger. That's a stinger. I have about 5 or 6 different types of grounds all rigged up on whips for my generator out there. I can show those a little more later. All right? But those parts, while they may be different, you may be using an electrode like this, or you may be using a bare wire like a coat hanger, or something that looks like a straightened out coat hanger. All right? Those parts are always the same. All welders have these parts. They have a way we control how hot it is, or how much filler metal we get, what filler metal, all that kind of stuff. It's all kind of the same. All right? Joey, what is horsepower?
Horsepower is how fast you're going when you hit the wall. Torque is how far you take the wall with you.
Yes, horsepower and torque. Horsepower is how far how fast you're going to be going when you hit the wall. Torque is how far the wall goes with you when you hit it. Voltage and amperage are along the same lines. Voltage is horsepower. Amperage is torque. Right? You can get shocked by a lot of voltage and not feel much effect. It doesn't take much amperage to kill it. All right? The wall socket has 15 amps. All right? This welder puts out probably 100 amps on the bottom end. That one out there puts 275 amps. I have a carbon arc torch over here that'll go to 500 plus amps easily. Okay? Now, let's go on to types of welding. By the way, if you'll